All right, welcome to Formative Assessment 4.3. A 4.25 kilogram block of wood has a kinetic coefficient of friction of 0.12, right? A smaller one, right? And then a static of 0.33 between it and the floor. Calculate the kinetic friction force and the maximum static friction force. So let's do that first, right? So here's this block of wood. Whoops, failure to draw a horizontal line. Okay, little block of wood. There's 4.25 kilograms. Okay. Now, I'm not going to do this every time, but the forces acting on this block in the vertical direction are, of course, gravity is down, right? Okay, so 4.25 times 9.8 is 41.65 newtons, right? So gravity is pulling down. Of course, it's not accelerating down. That's because the table's pushing up. And this is the reaction force or the normal force, right? Okay, so I got that by going 4.25 times 9.8. Okay, that's the force of gravity down, and then the surface pushes up with the same force, right? So this is the force that actually causes the friction force. So when we calculate these forces of friction, we're just going to go like this. Force of friction, the kinetic force, is mu times the normal force, which is, of course, mu times m times g, because mg, this is mg, right? That's our force holding this against the surface, right? Okay, so I'm going to go 0.12 times 4.25 times 9.8. All right, here we go. 0.12 times 4.25 times 9.8. And I'm going to store that bad boy in some register in my calculator because I'm going to use that. 4.998. Okay. Ta-da. Now, if we had to round that to 3 places, if we had to round it to there, we'd say it's 5.00 newtons. That is our dynamic or kinetic friction, okay? And now let's figure out the maximum static friction. Okay, this is as high as that static friction can get. Okay, so I'll write max. It's not always that. It's whatever it needs to be. In fact, if the thing's sitting on the surface and nobody's pushing on it, there probably isn't any sideways force. Okay, but that's going to be, we just use that bigger coefficient, this guy here, right? So 0.33, right, times 4.25 times 9.8. Okay, so 0.33 times 4.25 times 9.8. I'm getting 13.7445. Okay, so that's roughly 13.7 newtons. We got 5 newtons, 13.7 newtons, right? Okay, so now let's see. Those are our answers there, right? So we've got what the force is, right? So the static friction will be, that's as big as it can get to keep it from moving. If we exert 15 newtons of force on there, well, 15 is bigger than 13.7445. So yes, it would slide. Right? In other words, 15 is big enough to break it. That's how strong those little bonds are that are gluing this thing to the surface. There's little bitty microscopic bonds, and that's the maximum force they can feel before they break, right? So 15 breaks it free, and then the question is, what about 12 newtons? Well, 12 newtons isn't enough, right? So if we exert 12 newtons sideways, 12 is smaller than 13.7445. Right, so no, it stays. It stays stuck to the surface, right? Now, it's interesting because this is, one of these questions that, they would ask on like the AP test and people would get it wrong. Let's suppose I exerted 12 newtons to the left. This is my applied force, right? Is 12 newtons that way. They asked a bunch of AP kids, what's the static friction force to the right? And every AP kid said, well, it was 13.7 to the right, because they just had calculated that number, right? But if you think about it, it couldn't be 13.7 to the right, because if it were, it'd be bigger than that force, right? So that means if you push it to the left, it would actually, if there's 13.7 to the right, it would actually accelerate to the right. So it can't be that. It must be that this force is just keeps it from moving, right? So if I exert 12 to the left, the static friction force would be 12 to the right. Remember, this is a maximum limit. It's whatever it needs to be up to that point to keep it from sliding. Okay? Yeah. Kind of like the strength of a bridge or the strength of a wall or something like that. I can push on it and it'll push back with whatever force I push on it up to a point, and then I break the wall, which is a continual problem for me, you know. Anyway, hope that helps.